In this video, I'm going to talk about a quick review of cross products, also called vector products, and using the right-hand rule. A definition, a cross product is two vectors A cross B is defined as the magnitude of the vector A times the magnitude of the vector B times the sine of the smallest acute angle between A and B, and this cross products have a vectorial resultant quantity and is known as the unit vector n. So here's a vector A cross a vector B. This is the angle, smallest angle between the sine there. Here's drawn as vector A cross B, and the smallest angle between them is this theta. One thing to remember about cross products is they're not commutative. So A cross B is not the same thing as B cross A. In fact, it's the negative of that. We'll talk about that when we learn about how the right-hand rule works. So this part's pretty easy, except for remembering that sine of the theta is the smallest angle. So how do you figure out what n is? What's the resulting vector direction, unit vector direction of this cross product? Well, one thing we're trying to do is both coordinate systems you want to use, we're going to use right-hand coordinate systems. We'll talk about the difference between those two. But for most systems using right-hand coordinate systems, you use the right-hand rule to determine the direction of n. So here's some things to think about. The direction of n is perpendicular to both the directions of the vectors A and B. So if A and B are on the plane of this board, you know n is perpendicular to that. So what's a vector that's perpendicular to both those two? It's either going to be in or out of the board. So therefore, n is also, since it's perpendicular to the two vectors, there's a plane that contains those two vectors. So we know n is perpendicular to that plane. And the directionality of n follows the right-hand rule. So what is the right-hand rule? There's lots of ways and lots of tips of how to do it. This is the methodology I found the most convenient and most easy to remember. You can do with your fingers and things, but this is the methodology that I recommend. You can try another one, but I think this is the simplest one. There's 3 steps to this methodology. The first one is using your right hand. Okay, so right hand. You can't use your left hand. Align all of your fingers, just like this. Align all your fingers, make it align, okay? And point them in the direction of the first vector in this product, in this cross product. So for example, for this direction, that is A. Okay. Now we're going to learn later. So we know it's pointing this way. But the thing is, we don't know how am I going to spin my hand. But I know my hand's going to be like my fingers are all pointing in that direction. Everything's all aligned. My thumb, everything's pointing in that direction. The question is, I just don't know how the orientation I want to do theirs. So the second part. That's the first part. Second part. Now rotate your hand and arm. How much you can do. So I'm going to rotate until I'm able to direct. So redirect my fingers to point in the direction of the second vector when I bend my fingers 90 degrees inward from the original position. So let's try this one, A cross B. So I know this is what I'm going to do, and if I bend like this way, can I point my fingers in the B direction? B direction? No, I have to be like this. Because now my fingers have gone from this direction, they've gone in the B direction vector. Okay, so I've now been able to, I've oriented my hand in such a way that I can do this, and from the first vector, I bend my fingers 90 degrees to the original direction. They're now pointing in the B direction. So I've satisfied the first 2 steps. The third step is now fully extend my thumb, and the direction my thumb points is the direction of the unit vector n. So A cross B, second part, third point, stick my thumb out. My thumb is out of the board. So the unit vector direction of n for this cross product is out of the board. Let's try this for this example. Step number 1, everything points in the direction of the first vector, A. Now what is it going to be like this? No, I can't do it. I'm going to turn it and spin it like this. Now when I do that, I can do this. Now you can see, since those vectors aren't perpendicular, really you're going to have the component of B which is perpendicular to that, which is the B sine of theta, is that way. So I'm going to have A, if I have a hand like this, when I bend them, step number 2, bend it up, I can get them in that direction. Step 3, extend my thumb, I know unit vector of n is into the board. It's perpendicular to these two vectors. It's perpendicular to the plane of those two vectors. So it's into the board. So that's the methodology for doing a cross product and determining the directionality of the vector n using the right-hand rule and these 3 steps. Now, when you do the right-hand rule, you want to make sure you use a right-hand coordinate system. And the most common right-hand coordinate system we'll see will be x in this direction, y in this upward, so in the plane of the board, and then z will be coming out of the paper. Now, here's 4 cases I've looked at. I've drawn them like this in isometric to illustrate, but like in this view, so the unit vector I is in the direction of x, it's to the right. The unit in the plane of the board. Unit vector j is in the direction of y, it's upward in the plane of the board, and the unit vector k, which is in the z direction, is shown this way, but is really out of the board. Okay, so this is the most common orientation, and we'll learn why this is called a right-hand coordinate system. And this is isometric, but typically it's very commonly to draw, if you have the sheet of paper or a board, you're going to draw either a circle with a dot in it, or you're going to have a circle with an X through it to describe in or out of the board. And what this sign convention for in and out of the paper of the board really comes from thinking about an arrow. So if we have an arrow, it has the head, which has a point, and then has the fletchings on the back side of it. And if you look from this direction, okay, with your eye, you're viewing this direction. What you see is the head with the point. That's all you see. And so that's the convention for something coming out of the board, is a circle with a dot in the middle. If your eye is in this direction, you're looking at this arrow flying away from you, but you don't see this. All you see is the end of the fletchings, and so you see the X. So this designation for the circle with X means into the board or into the sheet of paper. So for this coordinate system, you can see that this is coming out of the board. I see the point of that vector, so I see that. There's other ways, that other right-hand coordinate systems to do it, and let's check if that is a right-hand coordinate system. So for a right-hand coordinate system, it's going to be defined as the right-hand coordinate system is only right-hand coordinate system if I cross j equals k. So x direction cross the y direction is the k direction system. If this is true, I think I said that. Yeah, is I cross j k. If it's yes, if that answer is yes, then it's a right-hand coordinate system. It's a right-hand coordinate system. Okay, so let's try that out for this example right here. So what's I cross j? Pause the thing right now and use your fingers, and then we'll try it out. Okay, so pause. Okay, now we'll resume. So what is I cross j for this coordinate system? Rule number 1 for the directionality. First thing, put the vector direction put all the fingers in that direction, I. Okay, it could be this way that we don't know quite yet, but we know when we're going to bend step number 2, bend our fingers upward, we want that to point in the direction of the second vector. Well, that turns out pretty easy. That's just like that. So this doesn't do it, but that does it. Okay, And then step number 3, extend my thumb. Well, that's out of the board. So I cross j indeed does equal k. So this is a right-hand coordinate system. So now pause the video again. Now try for, again, these are isometric views. Is this a right-hand coordinate system? Then yes or no. Is this a right-hand coordinate system, or is this one a right-hand coordinate system? So pause the video, use your right-hand rule, and come back. Yes, is it? Tell me what it is. Okay, so now we'll resume. So let's find out what I cross j is here. How do we do that? First step, all fingers in direction of I. Okay, then we want to bend. Okay, then we want to be able to, when we bend our fingers inward 90 degrees, we want to point them in the direction of j. So I, j. So that did that. Extend out. That is k. Yes. So yes, this is a right-hand coordinate system. How about this one? X is out of the board. So I'm going to have all my fingers pointing out of the board. Okay, and then I got to be able to turn my palm such that when I bend, I go in the direction of j, which is this way. So I, everything that way, j, k. Well, that's upward. Yes, right-hand coordinate system. Now let's try this one. Okay, I. Everything is in the I direction. Now how am I going to spin my hand or arm around to be able to get my palm towards J so I can do that? So this, palm towards J, now I can turn like this. Now because J is out of the board. J is out of the board. I cross J. Number 3, still my thumb. Well, my K is going downward. So this is not a right-hand coordinate system. This is not a coordinate system you'd want to use. So if you want to draw it, you'd have to turn the z direction down. That would be a right-hand coordinate system. But I think when you're thinking about it, probably this is the most common one you think about. And so, but any one of these are valid. They're all right-hand coordinate systems. They all follow the right-hand rule. For these 8 problems involving unit vectors, solve for the resultant unit vector and pause the video and so you can see the problems, and then resume it and we'll check the answers. Here's the 8 answers. You can check them. First of all, we can think about if I have a cross product involving 2 terms, unit vector terms, we know that the answer is out of the plane of these 2 terms. So I know if I have something involving an I hat and a j hat, the answer is going to be perpendicular to both of those, and the only answer is something in the plus or minus k hat direction. So for example, if it's involved in the j hat and the k hat direction, I know the answer is perpendicular to those 2, which means it's going to be something plus or minus the missing term perpendicular to one of these, which has to be the I hat direction. So let's start out with the first one, j hat cross I hat. So first part, so here's my coordinate system I'm going to use, which is a right hand to I hat here, j hat here, k hat out of the board. So first term, j hat cross I hat, all the fingers in the j hat direction, turn my palm towards the second term, the I hat direction, so I can bend my fingers in the second direction. Now my fingers are pointing in the second vector term. Third one, stick my thumb out into the board, which is a minus k hat. Number 2, I hat cross k hat. So fingers in the direction of the first term, I hat, turn the palm in the direction of the second term, k hat, so I can bend my fingers now in the k hat direction, thumb out, which is down, in the minus j hat direction. Third problem, minus j hat cross k hat. Positive j hat's this way, so a minus j hat is this direction, so the first term there, turn my palm in the direction of k hat, well, which it already is, so I can turn my fingers that direction. Third one, stick my thumb out, is to the left, which is in the minus I hat direction. Fourth one, I hat cross j hat. I hat's this way, palm towards the J hat, so I can, second step, turn my now fingers towards J hat, thumb out of the board, which is in the positive K hat direction. This is the definition of a right hand coordinate system, so I should know that one. Next one, minus I hat cross minus J hat. Minus I hat's this way, minus I hat's this way, J hat's up, so minus J hat is down, so fingers that way, palm towards the second one, so I can bend now in the direction of the second vector, it's down, thumb out, it's out of the board, which is positive K hat. Sixth problem, I hat cross minus K hat. I hat, this direction, minus K hat's into the board. Now I can turn my fingers into the board, thumb is up, which is in the J hat direction. Number 7, J hat cross minus K hat. J hat is up, minus K hat is into the board, palms towards the board now, so I can turn my fingers in there. Thumb goes out now to the left, minus I hat direction. Eighth problem, minus K hat cross I hat. Minus K hat is out, positive, minus is in there, so K hat's there. Rotate my palm towards the second term, which is I hat, so I can turn my fingers now towards that direction. Thumb out, it's down, which is the minus J hat direction. I hope you enjoyed learning about cross products and using the right hand rule to solve for directionality of the n hat vector.